Hey everyone, welcome to this lecture. In this section we are going to discuss regarding the concept of VPNs. So let's get started. So first of all, I will discuss regarding the concept of VPN and cryptography on a theoretical way, and then we will go ahead and do the labs for the respective VPNs types. So first of all, when you talk about VPNs, so let's write down some key points here. So we title that as VPN overview. I'll just write down the key points so that you can recap those if you're experienced, or might be for the freshers who are just beginning, you will be able to understand what is VPN is all about. So first of all, what is a VPN, right? So what is a VPN? VPN stands for virtual private network. Virtual private network, right? So it is basically, it's a secure connection method which is used to add privacy and security to your private and public networks. So if I need to draw this out for you, it's very simple. So let's talk about the simplistic way. Let's say I've got two branch office routers, and let's say that they are connected using an ISP in the middle, right? And they have the links towards the ISP, okay? And let's say that behind this particular branch office routers, you have got some LAN devices sitting, right? This is one of the example. So let's see, with this LAN devices are plugged to this router, okay? And let's say I label them. So this is my, let us say, branch router 1. This is, say, my second branch router 2, VR2, and they are connected via an ISP, internet service provider. And this is basically the LAN network which is running on some private subnet, say 10.1.1.0/24, and likewise this is the LAN network of branch 2 that is also running on some private subnet. Let us say it is 10.2.2.0/24, and the link towards the ISP that we have, it's running on a public subnet. Let's say this is over 123.110/30, and this is over, let's say, 124.1.1.0/30, okay? And the respective IPs are configured on this physical interfaces based on the IP address configuration. Now what we normally do is we have various types of VPN, right? We have site-to-site VPN, we have remote access VPN, MPLS VPNs, VPLS. So VPNs can be classified as either layer 2 VPNs or layer 3 VPNs, right? So we are focusing on layer 3 VPNs, where we deal with the IP addresses, right? So we normally form an overlay, an overlay tunnel, an overlay tunnel between these two sites, right? So VPN is always an overlay tunnel, right? So it is an overlay tunnel that you form between these two sites, and this overlay tunnel that you form will have a private IP subnet. So let's say this is 172.16.12.0/24 IP subnet, and on this particular tunnel interface, say it is tunnel 1, we have an IP address of 172.16.12.1, and over here you have got tunnel 2, and this is, say, 172.16.12.2, right? Now the whole idea is, if these two LAN segments, if they want to communicate together, so make sure that their traffic will be traversing via this particular tunnel network, okay? So ensure that right now, if you look into the routing table, when you configure the IP addresses respectively, you'll have the first connected network, which is for the private LAN 10.1.1.0/24, another connected network for that public one, which is 123.110/30, and then another connected network which is for the tunnel network, which is 172.16.12.0. let's say it's 24, right? That's the tunnel network. Good. So likewise, you'll have the routing table populated over here, as I'll have one connected network for 10.220/24, another connected for that public network 124.110/24, another network which is my tunnel network on 172.16.12.0/24, and that's my tunnel network. Right now, you need to have, let's say we are having a default route, right? So we tell that, hey, Mr. Branch Router 1, if you have any default route to reach anywhere on the world of ISP through the ISP, so the ISP IP address acts as a next hop, and same thing for branch 2 as well. So if this LAN users wants to communicate to anywhere in the world of internet, then the ISP's IP address acts as a next hop. But this LAN to LAN, if they want to communicate together, so if 10.1.1.0 wants to communicate to 10.2.2.0 and vice versa, their traffic should go over that particular tunnel network, right? So on a very basic overview, the packet header should look like that. So you have got certain information. So the packet will be divided into two parts, right? One will be your outer header, we call that as outer header, and one will be the inner header. Okay, so the inner header will have the actual data that the user is trying to send. The actual data the inner header will contain, and also it will contain the or you can say the payload, plus it will contain the original IP. So it is the original IP will be, let us say, from the source is from 10.1.1.1, and the destination is trying to go to 10.2.2.2, right? And then you have got the MAC addresses. So MAC addresses will be there in layer 2 as well, right? So yeah, so the data, the MAC address, the IP addresses are all part of the inner header, right? So basically data should not be part of the inner header, excuse me for that. Data will be part of the outer header, right? So data will be here, okay, right? And basically you need to add something called as ESP. The ESP protocol will be actually running that particular encryption, and with the outer header you'll have the IP addresses as well, right? So it will have the IP addresses of the tunnel interfaces, so which will be 172.16.12.1, right? And this is going to be 172.16.12.2. so ensure that these two tunnel IP addresses will be on the outer header, right? And yeah, the ESP protocol will be actually adding those encryption for the data, right, as well as the inner header, right? And the routing part will be actually dealt by the outer IP addresses. Okay, so make sure that these two outer IPs are actually binded to the public IPs on the physical interface. So if these two public IPs on the physical interface, if they are reachable, then the tunnel IPs will be also considered as reachable. All right, so the routing happens based on the outer header information. All right, so as the concept says, so VPN is a secure connection method that is used to add privacy and security to your private and public networks, such as the internet and the Wi-Fi hotspots. VPNs are commonly used by organizations and individuals to protect your any sensitive data and maintain this anonymity online. So there are multiple purposes of VPN. So let me write down the various purposes of using VPNs. Okay, so let's join some points here. So one of the example which I've drawn here was basically for your site-to-site VPNs, right? So let's say the next point is, what is the purpose of using a VPN? or a virtual private network. So far you understand that, okay, my traffic will be encrypted. So whenever I send this traffic over a VPN session or a VPN tunnel, my traffic gets encrypted, so my data gets encrypted. So the whole idea is VPNs, it will encrypt the data that is transmitted between your device and the VPN server, which protects it from any hackers and any sort of outside eavesdropper, right? Likewise, you have a feature called a secure remote access. So it will allow the employees to securely access your corporate networks and resources from remote locations. So let's say I'm at home and I want to access my data which is lying in the corporate data center. So I can use the concept of remote access VPN and I get access to the corp resources, right? Next advantages or purpose is to provide any anonymity and privacy. So generally VPNs, it does what? It will mask your IP address and the browsing activity, which makes it harder to track online and to track the user behavior. Okay, and another advantage what you get is you can bypass, you know, geo restriction, right? Restrictions, it means that you can access the content or services that may be restricted based on your geographic location. So might be you are in particular region and that regional laws or might be regional compliances, you know, blocks that particular URL that you're trying to access. But when you add a VPN, what happens is you can be, you know, get routed to or through a different geolocation to access the same URL, and that is possible, right? So yeah, so there are multiple ways, you know, we can talk about that how VPNs work. Okay, so the first thing first, you know, if you talk about remote access VPN, you will see in the labs as well, a VPN client is installed on the user's device, right? Then step number 2 is the client will connect to a VPN server via a secure encrypted tunnel. And step number 3 is all the network traffic is routed through the VPN server. Okay, so making it appear as if it is, you know, originating from the server location, right? So very simple that you can understand over here is you will have a VPN device, right? Let's say a remote user. Now this remote user will go ahead and talk to a VPN server. So I have got, let us say, a remote user here. This will go and talk to my organization's VPN server. It will go and connect to my organization VPN server, and from here the traffic will be routed to the corporate data centers, okay, which is hosting the applications, right? So if the user or the client sitting at a remote location wants to get access to this particular private applications, then it can form this particular VPN tunnel. We also normally call as a remote access VPN tunnel. All right, so let's make it a better font here. So it is also called as a remote access VPN tunnel, right? And it will be using a client based, you know, agent, right? So you know, remote access agent or a VPN agent will be used here, okay, to form that particular VPN session from itself to the organization's VPN server, right? It could be a, you know, firewall as well, right? And then the traffic is intercepted over here, and then, you know, so all the traffic that you sent on this particular VPN tunnel, everything will be encrypted and hashed, right? So all the traffic that you send will be encrypted using the encryption algorithm. All the traffic will be hashed using hashing algorithms to maintain the integrity of the data. And once the VPN server or the firewall receives those particular packets, so it could be done via certificate based encryption, right? So generally remote access VPNs works on certificate based, and all the encryption and the hashing keys are defined there. So which my remote access VPN agent will use to encrypt the user's traffic on that particular remote access VPN session towards the VPN server or the firewall, and it will intercept the traffic, it will decrypt those payloads, and then understand that okay, what application or what resources it is allowed to give access to, right? So yeah, so if this user wants to access any private resource, remote access VPN is one of the solution. And likewise, in the previous diagram which I've explained to you, that was for site-to-site VPN, right? So if there is a branch to branch and you need to have a site-to-site connectivity, the previous one was the example. All right, so let's remove this diagram a bit now. Okay, so the next term or the next thing that you can learn is types of VPNs, right? Types of VPNs are there. So you've got multiple, as I've told you. You've got remote access VPN. Remote access VPNs is one of them. You have got site-to-site VPNs, as I've told you, and you have got client to site, or might be SSL VPN, right? SSL slash TLS VPNs. Okay, so it is also a type of remote access VPN, that is SSL or TLS VPNs. It is also a type of your remote access VPNs where specific software or web-based methods are used for access. Okay, so yeah, the common VPN protocols that we use, common VPN protocols. I'm not discussing the layer 2 VPNs over here, so you might be wondering, okay, where is MPLS, where is VPLS, where is L2TP? Those are type of your layer 2 VPN. It is out of the scope of discussion in this firewall concept, so I'm omitting those. So common VPN protocols that is used are your IPsec, of course, as we know. So IPsec, it is often used for site-to-site VPNs, and also it is used for remote access VPNs. You've got another one called as OpenVPN protocol. So OpenVPN, so it is an open source which is known for strong security and configurability. You have another protocol which is called as L2TP/IPsec. So it is a layer 2 tunneling protocol, and it is used with IPsec for encryption. All right, and another one that you have, it is IKE version 2. So it is secure, it's fast, and it is often used on mobile devices. And another one that you have is called as WireGuard. So it's a new protocol which is known for high performance and known for its simplicity, right? So likewise, let's write down some key VPN benefits that you get. So what are the different benefits you get when you use VPNs? So far you might be able to understand that okay, VPNs will enhance security, especially on your public Wi-Fi, right? So you can say enhance security, especially on public hotspots or public Wi-Fi. It will have improved data privacy and protection. So whenever you want to access to any internal systems from remote locations, then VPN is your savior. Likewise, it will help to meet any regulatory compliance requirements for your organizations, right? And let's lastly talk about the different limitations of VPNs that we have. So limitations and what are the different considerations for VPN. So multiple factors. So VPN speed depends on the server load and the location. So I can say VPN speed depends on the server load and its location. It's not a substitute for other security measures. Like you cannot substitute VPN with firewalls, or might be you cannot omit firewalls or omit antivirus if you have VPNs, right? So I can say it's not a substitute for other security measures like antivirus and firewalls, right? Maybe blocked by certain websites or services. So if you are trying to access some sort of URLs or might be some destination through a VPN, you might get blocked sometimes. So yeah, that can be one of the limitation, by maybe blocked by certain websites and services. And of course, as we understand that VPN requires proper configuration and management to be effective. So needs proper configuration and management to be very much effective, right? So hope it's clear. You know what is the meaning of VPN, the different types of VPN that exist, right? The different protocols that we can implement to have a VPN. There is one protocol which I have missed it, but yeah, you can say is GRE, generic routing encapsulation. So that is also a protocol, a layer 3 protocol that can create a VPN. Okay, so you can use GRE with but GRE is clear text. So to encrypt the traffic on a GRE based tunnel, IPsec is generally used to run the encryption process. So we call that as GRE/IPsec. All right. So yeah, let's talk about basic of cryptography now. So I hope the concept of VPN is clear.